Hey guys, thanks for coming to watch today. Our lesson today is about the measures of segments that intersect in the inside of a circle. So remember, two segments in a circle, these are called chords. So if two chords intersect in a circle, then what we know is that the products of the lengths of the chord segments are equal. So chord segments are the pieces of the chord. So for example, if we had this circle shown here, point B is not the center of the circle. Chords AC and ED intersect at point B then. And here's what we will know about these. So the chord segments of the chord AC, the two chord segments are segment AB and segment BC. Those are the segments that together make up the chord. So here's what we know. AB times BC is going to be equal to the product of the chord segments of the other chord. So the two chord segments for the other chord are EB and BD. So if we multiply the chord segments together, they should be equal. Let's use this in an example. So it says find X. So we'll look at one chord segment at a time, or one chord at a time, and we're going to look at each of its segments. So we'll say EB is one piece of this chord. The other piece of the chord is BD. So we know EB times BD has to be equal to, now we're going to look at the other chord. The other chord is chord AC. One of the chord segments is AB. The other chord segment for this chord is BC. Once we have the equation set up, now we just plug in the values for each segment. So EB, the measure of that is X, BD is 10, AB is 5, BC is 12. Now we just have to solve this equation. X times 10 is 10x, 5 times 12 is 60. To solve 10x equals 60, you just divide both sides by 10. 60 divided by 10 is 6. So the answer for that one is x equals 6. Now let's try B. So we'll set it up the same way we did before. Look at one chord at a time and then find its segments. So the segments for this chord are JK and KL. That has to be equal to, now we're going to look at the other chord. So the other chord is chord PM, and the chord segments for this chord are PK and KM. Once we have the equation set up, now we can plug in the values. So JK is x plus 10. KL is x. PK is x plus 1. And finally, KM is x plus 8. Now this one's a little bit more complicated to solve, but you guys can do this. So hopefully you know to distribute first. And on the right side, you sometimes think of this, you might have heard FOIL. So let's do the left side first. Distribute. X times x is x squared. X times 10 is 10x. On the right side, we'll work on distributing the x first. X times x is x squared. X times 8 is 8x. Now we'll distribute the 1. X times 1 is 1x. 1 times 8 is 8. Once you've distributed everything, now we can combine like terms. So we have x squared plus 10x equals x squared plus 9x plus 8. Notice that there's an x squared on both sides, and on both sides it's 1x squared. If these are balanced on both sides of the equation, they can just cancel each other out, because think about it, if you subtracted x squared on either side, you'll end up with 0. So what we have now is just 10x equals 9x plus 8. To solve this, you get all the x's isolated on one side. So what I would do is subtract 9x on both sides. That gives me 1x equals 8. Therefore, x equals 8. All right, there are similar problems on the top of the next page. I'd like you to pause the video and try to solve those on your own first. Here are the solutions. Okay, next we're going to look at a real-world problem. So this says the true shape of a rainbow is a complete circle. However, we only see the arc of the circle that appears above Earth's horizon. What is the radius of the circle containing the arc of the rainbow shown? So what this is saying is that technically this rainbow is a piece of a larger circle. It's an arc of a larger circle. Obviously, this isn't a perfect circle, but maybe you can draw it better on your paper. Here's what we know. We know that this chord here, all the way across, is 5. And it also marks that each piece of that is congruent. So let's think about this first. How long would each piece be if the total is 5? Well, 5 divided into 2 equal pieces, each of these pieces must be 2.5 miles. So this chord has 2 chord segments that are each 2.5 miles. Now, for the next one, we need to draw the entire chord. Something that you should know is that if 2 chords create a right angle, then this chord, one of the 2 chords has to be either a radius or a diameter. So we are going to draw this, and I know that this is a diameter since this is a right angle that's created. So since this full thing is the diameter of the circle, we can say that this piece of the chord, this chord segment, would be equal to the diameter minus 0.7, since this part of the chord segment up at the top is 0.7 miles. So if we can solve for the diameter, we'll be able to find the radius. So let's set it up. For our first chord, we have 2 chord segments. The first chord segment is 2.5. The other chord segment is also 2.5. For the other chord, this vertical chord, which happens to also be a special chord, it's a special chord because it's a diameter as well, we have 2 chord segments. The first chord segment up at the top is equal to 0.7. So this is one piece of the chord. The other chord segment that forms the diameter is this part at the bottom. This is the other chord segment, and we said that this chord segment is equal to diameter minus 0.7, or d minus 0.7. Now we should be able to solve this. 2.5 times 2.5 is equal to 6.25. On the right side, we have to distribute. 0.7 times d is 0.7d. 0.7 times 0.7, in other words 0.7 squared, is equal to 0.49. Now we can solve this for d, diameter. What we'll do is add 0.49 on both sides to try to get d by itself. Whoa, sorry. Okay, so on the left side, 6.25 plus 0.49 gives you 6.74. We're almost there to get d by itself, but we still have 0.7 times d. To get it alone, we have to divide by 0.7, and we have to do that on both sides. So we get d is equal to, you'll have to plug into your calculator, 6.74 divided by 0.7. It'll give you a non-repeating decimal. It's like 9.62857 or so. Once you find the diameter, we know that the radius is equal to the diameter divided by 2. So it's 9.62857 divided by 2. You can just go ahead and click divide by 2 on your calculator. And you should get that the radius is equal to about 4.81 miles. All right, there's a practice problem for you on the top of the next page. I'd like you to pause and try it on your own. Here's the solution. This is showing another way to solve the problem using a right triangle. You could have also solved it using the product of the chords as well. As long as you get the same answer, that is correct. Your homework for tonight is on page 753. You have numbers 2, 6, 8, and 14. And your reflection question is number 29. Make sure for this reflection question that you explain your answer fully and specifically using 1 to 2 complete sentences and correct vocabulary. You can use a diagram in addition to your explanation if it's helpful, but you must have the 2 sentences still. Thanks, guys. Have a great day. See you or talk to you on Thursday. Bye.